Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In this lecture, we'll start with the new topic that is random variable and probability density function and probability mass function. So, what is a random variable? We all know what is random variable. A random variable is a variable, by the name it suggests that it is a variable which is randomly selected in an experiment or an event. Suppose we have an experiment where we throw event is throwing a dice. Suppose throwing a coin, two coins. This is event. Now from this we have the random variable x. Let us represent it by x. Then the random variable, if it represents the number of heads which appear. So our table of this would be like this. Here, if we say that we are talking about x and the probability of x is represented by x. Now, number of the total outcome or the sample space of this would be when two dice are thrown. First is head, the second is head. First is head, second is tail. First is tail, second is head, both are tails. This is known as the sample space of the outcome. So now x represents the number of head. The maximum number of head can be 2, can be 1, or can be 0. And the probability when the head is 2 is 1. There is only one chance that it can occur 2 out of 4 chances. Then the probability that head occurs is once. There are two chances. First head is occurring, then tail is occurring, then first tail is occurring, second head is occurring. There are two chances. Both are having 1 by 4 plus 1 by 4 probability, and the total will be 2 by 4, which is nothing but half. So there comes the probability. And the third one is when no head occurs. No head occurs only one chance out of 4, so it will be 1 by 4. So this is what random variable denotes. Random variable denotes the question, exact question that is asked to us. Why are we finding probability of what we are finding probability? This is known as the random variable. Now there are two kinds of random variable: discrete random variable and discrete random variable and continuous random variable. I can also write it in RP. So discrete random variable, when a random variable takes the values or discrete values, which is the integers 1, 2, 3, 0 also, 4, and all these values, when the random variable takes whole numbers as the value, then it is known as discrete random variables. Whereas when the random number when the random number takes any value from minus infinity to infinity, then it is known as continuous random variable. It can include 3 by 4, 1.5, 2, and anything like that. These are known as continuous random variable. So discrete random variable and continuous random variable. Now what are the probabilities of these random variable known as? Here it is known as probability mass function, and represented by small fx. And here it is known as probability density function, and represented by small, sorry, here it is represented by small fx, and it is represented by small px. there are two rules here. In discrete random variable, this summation of probability over x should always be equal to 1. We all know that probabilities when added is equals to 1. You can see it here also. If we add 1 by 4 plus 1 by 2 plus 1 by 4, this will be, denominator will be 4, 1 plus 2 plus 1, which is 4 by 4, and hence it is 1. So everywhere the sum of probability will be equal to 1. This is what we are talking about here. The sum of probability should be equal to 1. And the second one is probability mass function should always be greater than or equal to 0. This is also the case of our probability mass function. Now, if we talk about probability density function, this also has same things. The second one is same, that probability density function should always be greater than equal to 0. This is one case, but here we are talking about continuous. So instead of summation, it will be integration. Integration from minus infinity to infinity, fx dx should always be equal to 1. The range should always be equal to 1. That is the only difference between continuous random variable and discrete random variable, and these are the formulas how we calculate one. For all x, for all x. So this is how we solve for our formulas. Now let us see some of the question how to attempt them in examination. Here we have been provided with the probability mass function, means it is discrete, and you can see here x has values 1, 2, 3 up till n. All the discrete values have been given, and they have given us the PMF. PMF Px is equals to kx square. Now we have to find the value of k. We know that summation over x Px should always be equal to 1. Now summation over x. Here you can see that all these are nothing but natural numbers, 1, 2, 3 up till n. So summation over x goes to 1 to up till n. K x square should be equal to 1. K can get outside because k is in multiplication with all of them, and this is nothing but summation over x goes from 1 to n x square, which is equals to 1. Here this is summation of natural square of natural numbers, and we all know the formula of summation of square of natural number, which is n plus 1 into 2n plus 1 upon 6, which is equals to 1. And since we have to find out the value of k, k will be the reciprocal of this, which is 6 upon n plus 1 to n plus 1, which is our option number D in this question. Okay. Now moving forward to another question. Here we have been provided with probability density function, and we have to find the probability of x is less than or equal to 1. Now this is a continuous random variable, and we have to follow the law of integration. So they have given us the limit from -2 to 2, but we have to find probability of x is less than equal to 1. Probability x than equal to 1, the limits will be -2 to 1. Fx dx. Now fx is 1 by 4 when x lies between this range and 0 elsewhere. So I will write -2 to 1. Fx is 1 by 4 dx. Now integrating this, we will be getting x with the range 1 minus 2 and 1 by 4 here. And if we subtract it, 1 minus minus plus 2, which comes out to be 3 by 4, which is our option number D. This is simple integration. You just need to know the formula. That's how we have completed this. Now moving forward to the next question. This question is a little bit tricky because it has gamma distribution in here. So let us solve this. This is also a continuous distribution PDF. What does this question says? This question has given us the PDF and we have to find the value of k. We know that integration from minus infinity to infinity, but here the range is 0 to infinity. So we'll put it 0 to infinity. Integration from 0 to infinity fx, which is k e raised to the power minus x raised to the power minus half, should be dx should be equal to 1. Now here if we see it clearly, k we can take outside. Integration from 0 to infinity e raised to the power minus x raised to the power minus half, I can write it as half minus 1 dx equals to 1. We can write it that, right? Now we know that integration of 0 to infinity e raised to the power minus y raised to the power n minus 1 is equals to the gamma is equal to gamma n. So here we can see that in place of n here is half. So this will be k into gamma of half, which is equals to 1. Now this also should be known that gamma of half is nothing but pi. Gamma of half has the value pi. So it can be written as k into pi is equals to 1 and k is equals to 1 upon pi, which is our option number D. Sorry, it will be k upon root pi. So it will be 1 upon root pi, which is our option number D. Gamma half is equals to root pi, and that's what we have done here. Now moving forward to another question. This is one of the PYQs of our statistics ISS examination. Here we have been given probability mass function Px. So Px is nothing but equal to k into p raised to the power x. For all x takes the value, even value 0, 2, 4, 6 and so on. Then we have to find the value of k. Now we know that summation over x px should be equal to 1. Summation over x into k p raised to the power x is equals to 1. If I take k outside, then it will be summation over x p raised to the power x is equals to 1. K outside, summation over x p raised to the power x, we can put it like p raised to the power 0 plus p raised to the power 2 plus p raised to the power 4 plus p raised to the power 6 and so on up till infinity. They have not given us the last value. And here instead of p raised to the power 0, I can write it as 1. So if we see this clearly, this whole is a geometric series with r equals to p raised to the power 2. So the sum of geometric series will be a, which is the first term, 1 upon 1 minus r. 1 minus r is the ratio, the constant ratio which is dividing. So it is getting multiplied by p raised to the power 2, 1 minus p square, which is equals to 1. And from this we can conclude that k is equals to 1 minus p square, which is our option number C. This is how we attempt the questions in the examination, and this is how easier the concept comes. It's just that you need to know the basic mathematics and the problem, how to solve this problem. Now moving forward to another question of ISS only. Here they have been provided us with PDF and they have told us to find the value of A. So we know that if we in continuous random variable from minus infinity to infinity, fx dx should be equal to 1, but they have divided the intervals into sub intervals. So we'll take the sub intervals. 0 to 1, fx is ax dx plus 1 to 2, uh, PDF is a dx plus 2 to 3, it is minus a x plus 3a dx should be equal to 1. Now instead of minus ax and 3a, I can write it here as 3 minus x, and a I am taking outside. So if we integrate ax, a will come outside and x will be integrated as x square by 2 with the limits 0 and 1. Plus a will come outside and x is integrated with the limits 1 and 2. Plus a will come outside and 3x and minus x square by 2 will be integrated with the limits 2 and 3 is equals to 1. Now here we can say that it is a by 2 plus a plus, if we put it 3x minus 9 by 2 minus, let us put it a into 9 minus 9 by 2 minus 6 plus 4 by 2. This will be minus 5 by 2, which is 2.5 and zero point 0.5 only. So our answer will be a by 2 only, which is equals to 1. If we add all of them, a by 2 will be a only, plus a is equals to 1. 2a is equals to 1, a is equals to 1 by 2, which is our option number B. This a little bit difficult integration, more of calculation part, but this was an easier one as compared to the other ones. Okay, now moving forward to another and the last kind of question they ask in the examination on this topic. They have asked the range of alpha. They have given us here the CDF. CDF is nothing but the differentiation of PDF, integration of PDF. CDF is nothing but integration of PDF from minus infinity to infinity. So if we have to find fx, then it will be differentiation of CDF, cumulative distribution function. So for all ranges, let us find the CDF. So fx will be equal to, if we differentiate 0, it will be 0 only. So 0 for x is less than 0. If we differentiate x by 3, it will be 1 by 3 with respect to x, where range is 0 to 2. If we integrate this, it will be 1 minus alpha only. Rest other are independent of x, so they will be 0 only. From the range 2 to 3. And the last one is 1. If we differentiate it, it will be 0 for x is greater than equal to 3. This is our PDF that we have calculated from CDF by differentiating this. Now we just have to put it in integral form so as to find the value of alpha. Now integration of PDF from 0 to 2, 1 by 3 dx plus 2 to 3, 1 minus alpha dx. It will be x 1 upon 3 with the limits 0 to 2 plus 1 minus alpha x 2 to 3 should be equal to 1. Summation should be always equal to 1. That's what we are doing here today. So if we put the values, it will be 2 by 3 plus 1 minus alpha is equals to 1. 1 and 1 will get cancelled. So 2 by 3 is equals to alpha. Alpha is exactly equal to 2 by 3. Then only this function will be a continuous random variable or distribution of continuous random variable. So if and only if alpha is equals to 2 by 3. This is your answer. This is how we attempt the question in the examination. I hope that all this topic has been clear with all of you. It was an easier one because we have been doing statistics from a long time, so this topic is a bit easier. And if you have faced any doubt, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.